Hi there, this is exercise 7D. I've split it into two parts. This first part is going to be just looking at the partial fractions, and in 7D.1 we're going to try to do things like integration, which is an important part of what we need to do. But this is just meant to be a quick practice, and I'm not even going to ask you to do necessarily any exercises, particularly from 7D just yet, and we'll perhaps wait for you to have done 7D.2. This you've seen before, but you'll notice I've included this third row. So when I say you've seen this before, in normal maths, when we did partial fractions, we looked at the fact that sometimes you get linear factors, and in those examples you go a over the ax plus b over c plus d, a number over each of the factors. And then we also saw what we called repeated linear factors, and these were the same, but they invariably had a squared in somewhere. It could be either one of these two. And the trick is on these, if you remember, you have to end up writing it twice. That squared bracket you write twice. You write it once as just ax plus b, and then ax plus b all squared. And here the squared bracket is cx plus d, so that's why it appears twice, once with a square term. Now, when we did that, I cut off this final row. And that's because we only need this in further maths. But in further maths, this suddenly becomes important. And it's what happens when we get a squared thing on the bottom. I don't particularly know why it says x squared plus. I would just think of that as x squared plus c on the bottom. And when you have x squared plus c on the bottom, or it could be something a bit more complicated, I suppose, but let's assume it's x squared plus c. And what we do is we have to put the power on the top is always got to be one less than the power below it. So that's why when we have a linear factor of ax plus b, that's got a power of x for the x to the 1, sorry, and therefore the a has no power, if you like, or power 0. And here we've got a power 2, and that's why we have a power 1. Theoretically, if we had a cubic one, we'd have to have a quadratic on the top. But these are the type that I want us to be able to try today. So let's have a go at these. This is just a reminder, of course, of what we've done before. You can tell that because both of these are linear factors. So all I can do is I write 2x minus 5 over the double bracket. And of course I write a over the first one plus b over the second one. And then I write the right hand side with a denominator similar to the left hand side. And when I do that, they get times by each other. And they get times by each other. And you should recall that I don't particularly then bother writing the bottom, I just put the top. Because the bottoms are the same, and therefore I can ignore them. So what we now do, of course, is we set x equal to a number which makes the bracket disappear. So when x equals 1, for instance, 2 minus 5 is minus 3. And if I put 1 in here, I get 3b. So therefore b equals minus 1. And the second thing I do is I set x equal to minus 2, because that will make that equal to 0. And I reckon that's minus 9. 2 2s are 4, so minus 4, yeah, that's right. And when I put minus 2 in here, I get minus 3a. So is a therefore equal to 3? And so that implies that this initial thing I started with can be written as a, which is 3 over x plus 2, minus 1 over the x minus 1. And hopefully that's what the answer says. Yes, it does. So I want us now to look at the harder ones. Well, not necessarily harder ones, but different. They're an extension of what we've seen before. And you'll notice this is a linear factor. That's exactly the same as before. But this is our quadratic. And it's how we deal with this quadratic factor that we have to deal with now. So I'm going to write 2x plus 3 over this 3x minus 2x plus x squared plus 1. And this is equivalent to, well, it's just a over the 3x minus 2. But this is the tricky bit. It's now bx plus c. We have to assume it's a a linear term, and we don't know if there is any x's, we don't know if there's any numbers, but we have to assume both are there over the x squared plus 1. Now let's go back right to basics. Let's not miss out any steps this time because it's the first time we've seen one of these. So I'll write it all out. And the left hand side this time then is going to equal, and I'm going to pretend it's 3x minus 2 x squared plus 1 there, and obviously you can see that gets times by that. This is actually not a big shock, but now I've kind of got a more complicated expression here, and I times that by that. And therefore I can write the tops only because the bottoms are the same. And what I'm thinking of doing here is I want to multiply those out. Perhaps I won't. Perhaps I'll just write it like this. And the reason is, I suppose, it's very obvious at the moment if I put the right number in, that whether or not this left-hand side, this right-hand thing or this left-hand thing will disappear. If I multiply it out, it won't be quite so obvious. So it might be best us leaving it out there. So now we can do a little bit of what we did before. Now it's not even a very nice one as much as what number do we put into that to make it disappear? Well, I actually think it's 2/3, because if I put, you change the sign and divide by that front number, so that's not a very nice number, but I'll put it in anyway. If x is 2/3, the left hand side becomes 2x plus 3. So let's do that. 2 times the 2/3. What was it? It was plus 3. So I've just done it on my calculator to make sure I don't make daft mistakes. 13/3. Now I've got to put it into here. 2/3 plus 2/3 squared is 4/9. I then have to add 1 to it, which is obviously 13/9 times by the a. And the whole reason of doing it is that it becomes 0 when I put that 2/3 in. But 0 times by anything will still be 0, so effectively this is it. And does that make a equal to 3? 13/9 times by 3 would give me the 13/3, yeah. So I reckon you can either divide it or whatever you need to do, but you get the a equals 3. Now the other b and the c are more complicated to get hold of. What I have done in the past is I've used a new technique called equating coefficients, and you look at the number of x squared terms, for instance, over here. So I'm going to look at x squared terms over here, and the x squared terms, you'll notice actually none. So on the left hand side I've got none, but if I multiply this out I get a x squared, and how many? I reckon 3b x squared. Everything else wouldn't give me an x squared to multiply out. Now I know a is 3, so effectively that says 0 equals 3 plus 3b, or b equals, I reckon, minus 1. Now that was looking at the x squared terms. Now the other thing, don't do the x terms, they're always more complicated, more things, but just do the numbers. So for that reason I'm going to write numbers over here. If I look at the numbers on the left hand side, I've got 3, and that is equal to what have I got? I've got an a times y1, and what numbers have I got? Well, the only thing that's going to give me a number here is that times by that, which is minus 2c. And again, I know that a is 3, so I reckon 2c must be 0, or c must be 0. So that's actually quite nice in as much that the c disappeared. How am I going to write this then? Well, I go back to this. I wrote initially a over 3x minus 2, so that's 3 over the 3x minus 2. I wrote bx plus c. Well, my b was a minus 1, so that's actually a minus x. And I can do that because the c was 0. Completely ignore the c over the x squared plus 1. That's what I think out to. Let's check. Yes, that's worked out right. So it's not often one of the numbers disappears, but it can happen. In this case, the c disappeared. Now, here's another example. Let's try and get better at these. So I'm going to try and jump ahead of fraction this time, perhaps not take quite so long. So x squared plus 3 on the bottom. This is equivalent then to a over the first one. And because the second one is a quadratic factor, I have to write bx plus c over the x squared plus 3. So when I make the right hand side have the same denominator, I'll get a lots of x squared plus 3 plus bx plus c times by the x minus 3. And I've done it all in one step there to make it speed it up a bit. So x then is equal to 3, because that will sort this bracket out. And when x equals 3, I'll get, what's that, 9? 36 on the left hand side is equal to 3 here, 9 plus 3, I reckon 12a. So a equals 3. Notice this all disappears. Now I'm going to look at the x squared terms. This is what we call equating coefficients. On the left hand side I've got 4. And on the right hand side I've got a plus b again. Just you multiply those out. So a is 3, I reckon therefore b must equal 1. So now we look at the numbers. And the numbers on the left hand side of this line, of course we're looking here, it's getting a bit more confusing now. There's no numbers on the left hand side. So there's 0 equals, now if I multiply out the numbers on the right hand side, I get 3a there, plus, what's this going to be, minus 3c. And of course a is 3, so effectively that means 0 equals 9 minus 3c, or c equals 3. So writing it up here, I reckon we get the a is 3 over the x minus 3, plus bx minus, well, b is 1, so it's x plus 3 over the x squared plus 3. That's what I reckon. I've got a minus there. Is that just a mistake? We just check that. Yeah, I just checked it. It was just a mistake when I typed it in. So it's a plus. So now don't get confused, by the way. This is an example one we've done before. This is not the same thing. This is back to our repeated factor again. So if I was doing this, I would write this as x squared minus 13, obviously over this repeated factor, x plus 2, and that's equivalent to, remember, now when it's repeated, you go a over the squared one, repeated one, plus b without the squared, just x minus 1 on its own, plus c over x plus 2. Now I don't intend to do this now. I only put this in to highlight in your mind that these are different. The one I've got here is example 2 from down here. It's one of these. Whereas what I'm looking at today really is number 3. So I'll give you the answers for that so that you can do that in your own time and make sure you get the right answer. So here I'll very quickly then another example. This has got a quadratic factor on the bottom. So it's, if I was to do this question, obviously I'm going to write a over the first one plus bx plus c over the second one because the bottom is a quadratic. I write it out, 3x plus 1 is equivalent to the a lots of 2x squared plus 1, hopefully we're getting good at this now, plus the x times bx plus c. So when x equals 0, the left hand side gives me 1, that disappears, this gives me a, so I know what a is. Look at the x squared terms, I've got nothing, equals 2a plus b. So a is 2, so b is minus 2. And if I look at the numbers, I get 1 equals a, just a. So in this example, I've got to look at the x terms instead because the numbers didn't get me anywhere. So the numbers of x's is 3 on that side, and that equals c. So I've got the c. So this was my answer, and that's why I've got what I've got. So what I want you to do, oh, do check that that works, by the way. I was too lazy to write it out. So what I want you to do is hang fire a bit on this. You might want to have a quick look at it. But on exercise 7D.2, we'll do it, all the questions, and then you should be able to answer them all. Best luck.